I'll post the review up for any in case you missed something, okay? All right, go ahead and click. Well, actually, if you're logged in, it should ask you for your name. Put your name in there. Again, you can work in groups. You can have everything out, but I'm not going to give you a lot of time as we move through this. I want to put you under a little bit of pressure to simulate the actual exam. I'll give you 1 minute starting now. Go. I hope you remembered what I said you need to have for this answer after that quiz. I hope you remembered. Okay, 9 of 14 people have answered. "20 seconds. "10 seconds. 5, 4, 3, 2, 1. Stop. Nobody submit anything, please. At this point, I'm going to tell you what I would award in points out of 5, all right, and why. Study of algorithms, step-by-step. Okay, study of algorithms, yes, but then you go into what an algorithm is. So I'm actually going to take points at that point, right? So it's the study of algorithms, but you're still missing a lot of stuff, and I would have given you just 3 if you would have put the study of algorithms in problems, but I want to take away 2, or take away 1. That gives you 2. Study and creation of algorithms. I'd give you a 2 or a 3, a 2 or a 3. I would give you full credit for this answer. Study of algorithms, study of problems, creating algorithms, taking into consideration the mathematical, the linguistic, and the hardware realizations, right? Linguistic realizations. What is the best language to use for the problem? There are a couple of thousand different languages that are out there. You've just experienced Java. In my one class, we're going to play in 6 different languages in 1 semester for web development. A lot of your favorite websites are using 6, 7, 8 different languages at any given time to give you that stuff. So what are the best languages? Hardware realizations. The algorithm we're developing, is it going to be running on a phone? Is it going to be running on a high-performance computer cluster? Is it going to run on a desktop? So that's the hardware realizations. The mathematical considerations, that goes back to those efficiencies. Right? Are we making it as efficient as possible? By the way, you can't always make it perfectly efficient. It's not going to happen. There's always trade-offs. Study of algorithms. Algorithms. I've already told you what I would do for that. Good. All right. At least nobody said it's the study of hardware. Good job. Next. What's an algorithm? 1 minute. "30 seconds. "15 seconds. 5, 4, 3, 2, 1. All right, please stop. All right, so what do we have here? Let's have a look. Algorithm is a step-by-step set of not ambiguous, even though that's spelled wrong. It had to be unambiguous instructions, not installations, within a finite amount of time. Probably give you about a 3 on that. Step-by-step set of unambiguous instructions, complete a task efficiently in a finite amount of time. Still missing something. Give you a 3, maybe a 4. 3, maybe a 4. Unambiguous, finite amount of time, still missing something. Unambiguous, finite, still missing. Here we go. Unambiguous, finite amount of time, and is correct. That is a 5, right? Step-by-step set of unambiguous instructions, halts in a finite amount of time, and solves the problem correctly. All right? See, make sure there's nothing too out of this world on the rest of these. All right, everybody is pretty much on, okay, an algorithm is code. That would be a big 0. It is not code, right? All right, next. List the attributes of a good algorithm. Now, before you dig into this one, it's in the book. I don't know if Becca explicitly covered these. An algorithm, you just defined an algorithm, right? What are the attributes of it? You are a human being, right? Attributes are the descriptors of you. What's your hair color, what's your eye color, what's your skin color, what's your height, what's your stature, right? Those are attributes. They are descriptors of a person. So what are the attributes of a good algorithm? I'll give you a hint. One of them is efficiency. That's the most important one, is efficiency. What are the others? Go ahead. You can discuss this with your neighbor if you want, if you really, really want. Thirty seconds. $15 seconds. 5, 4, 3, 2, 1. Stop, please. All right. Don't put anything else in. All right. Even if you're like, well, I want mine checked. Nope, don't put it in. All right. Efficiency. Yep. At least you got that, right? So I give you 1 for efficiency, right? Efficiency, unambiguous, simple, little resource, quick, correct. No. You started describing, with the exception of correct, you just started describing the same thing over and over and started describing what an algorithm is. Same thing there. Same thing there. This solves a given problem as quickly as possible is a definition of efficiency, right? Ease of understanding, clarity, elegance, and efficiency. Good job, right? Ease of understanding, that is, how easy is it, not for the user, but for your team to understand your code. Now, we're missing one. This is going to get you to 4 out of 5, right? Elegance, that is something that just comes with time. That is the style of your code. It's kind of like the pro athletes or the Olympians, right? They are so elegant. I can only dream of skiing moguls the way those guys, I can truly dream it, right? I'm like, yeah, I used to ski moguls like that. Yeah, I'm a legend in my own mind. There's no way I skied like those guys do. I'm a big skier, by the way. Same thing for basketball players, for football players, right? For ice skaters, for musicians. There's a certain elegance. Even an artist. You ever watch a true artist just draw something out of thin air? It's like, oh my God, how did they do that? Right? Elegance comes with time, and some of it is talent. Efficiency, organized. Okay. So far, this just be like a 1, 1. 1. Elegance and correctness and efficiency. So you effectively computable, I think is what you're after. Efficient, correct time. All right, so the other one is ease of maintainability. All right. How easy is it to maintain your algorithm? You know all those bug fixes that you get? That's what we're talking about with maintainability. How easy is it to fix bugs as they're discovered? Security bugs, logic bugs, so on and so forth. All right? And that would be all of them. All right, next. Give an example of an output statement in pseudocode. I'll give you 30 seconds on this one. Go. Only 30 seconds. Example of an output statement in pseudocode. Ten seconds. 5, 4, 3, 2, 1, and please stop, whether you have it in or not. All right, let's have a look. An example of an output statement in pseudocode. Output, please enter. That's why I didn't want you to put anything else in. Output, please enter the final price here. I'd probably give you a 3 or I'd give you a 4 on that. It really should have said something out. Yes, print. Here's an output statement. Yes. No. I'd give you a 0. Why? What is it? Yeah, you all recognize that. That's Java. That's not pseudocode. It's not pseudocode at all. That'd be a 5. That'd be a 5. I'd give you probably a 4 on that. Just simply because you should put it in quotes still. That's all. Still give you a 5. 0. System.out.println. All right. My coders, when I ask for pseudocode, I need pseudocode. Next. System.out.println, TGIF is an example of a conditional statement, true or false. I'll give you 15 seconds to decide. Five, 4, 3, 2, 1, 0, and stop. All right, how'd we do? I'm hoping, but I bet it didn't happen. I'm hoping that everybody answered false. Whew. That is what type of a statement? It's not a conditional statement. Sequential statement. Absolutely, it's a sequential statement. All right? A conditional statement asks a question. Right? You know I'm recording this all right, Carlos? You know, the better thing to do is actually write it down. I can feed you study after study after study that shows the most successful 4.8 students write everything down and they take a few pictures. Pictures back you up. Asks a question, conditional statement asks a question based on the condition or based on the answer to the question. If it evaluates to true or false, follows the path. Now, if you're doing this and you're not thinking about it or you're doing it on purpose, answering it the wrong way, you're setting yourself up for failure as well. You're setting yourself up to always practice inputting the opposite. Next, ready? 15 seconds. Go. If age is greater than or equal to 18, print, you can vote. This is an example of a conditional statement, true or false. 5, 4, 3, 2, 1. All right. I'm crossing my fingers. I'm hoping I got 100% on true. Yes. Yes, you're getting it. All right. Next. Translate that Java statement to pseudocode. You at this point have done enough to translate that to pseudocode. I'll give you 30 seconds. Just think about what it's doing. Ten seconds. 5, 4, 3, 2, 1, and stop, please. Even if you don't have it in, don't type anything else in. Don't hit enter anything else. Here we go. I want you to think of it this way. When the computer encounters that on the console, it pauses. That's the statement that pauses and waits for you to put something in. So that should be a get statement. Get some number from keyboard. Yep. Initializing some number. Nope, that's not initializing it. Get some number. Yep, get is the keyword. User input equals an integer number. I would give you a 4 on that, maybe even a 3. This, you should have at least some number in there to show that relationship, right? To show that you understand what's going on. I give you some points. Get some number. Yep. Get some number. Get value for x. I give you a 4. Again, because I already told you it's called some number. That's the name of the variable. So let's be consistent with it, right? Get some number. I'd give you full credit on that, even though you put a space in there. By the way, in the upper level classes, they would give you a 0 on that because some underscore number is different than some number with a capital N. All right? What is the power? Two different things. The power of representing algorithms using pseudocode instead of jumping straight to code. Why do we want to represent pseudocode? I'll give you 1 minute on this one. Thirty seconds. Fifteen seconds. 5, 4, 3, 2, 1, stop. All right. Please don't input anything else. Two different things I'm looking for. Debugging, logic debugging, okay? Make sure you understand the problem. I'll probably give you about 3 or 4 points on that one. Pseudocode gives you an appropriate reference point for organizing and revising the program. I'll give you 3 or 4 points. Understand the problem. Think about less Java. Okay, yeah, 3 or 4 points. 3 or 4 points. Oh, wait. Oh, no, still 3 or 4 points. Okay, 3 or 4 points. Yep, you're right, still 3 or 4 points. 3 or 4 points. Yep, 3 or 4 points. 3 or 4 points. 0. All right. So everybody has, so it's going to logically organize our thoughts without thinking of the Java, right? Without thinking of the syntax and how do we set things up. But what you missed was it enables us to easily translate into the most appropriate language. Remember that linguistic realization? We don't know what language sometimes we're going to be writing in, right? So it helps with that translation into a language. That would give you the 5 points. Overall, I think you all have the gist of it. I'm pretty proud of you on that one. All right, here we go. True or false? 15 seconds. Evaluate B less than Y. True or false? Does that evaluate to true or false? 5, 4, 3, 2, 1, stop. All right, how'd we do? B is 6, Y is 56. That should evaluate to true. One person missed it. B, 6, Y, 22. Next. This has an or in it. 15, I'll give you 20 seconds on this one. Remember, it's got an or. Anything evaluates to true, the whole thing evaluates to true. Five, 4, 3, 2, 1. Stop, please. All right. So x is not equal to z. X is not equal to z. Well, here's the deal. X is equal to z, so that actually evaluates to false. However, there's an or, so if this evaluates to true, we're good. So B6 is greater than A. That's true, so this should be true. And most of you got it. Good job. Next. X is not equal to z. 15 seconds. Five, 4, 3, 2, 1, 0. All right. So x not equal to z. Well, that is false because x is equal to z. I know that reverse logic is rough, isn't it? Good news is on the exam, I don't only give you like one of the reverse logic, but I'll give you like 5 of these problems. All right? Well, you got to evaluate each worth like a couple of points. All right? Here's an and. So everything in the and must evaluate. I'll give you 20 seconds on this one. Must evaluate to true, all of it. And stop. All right, how'd we do? Should evaluate to true, right? Because x is equal to z, x is equal to z, and x is not equal to y. X is 22, y is 56. It's not equal. Exclamation means not, right? Next. All right. Jeopardy style. Jeopardy style. A named storage location. 20 seconds on this one. Five, 4, 3, 2, 1, 0. All right. A named storage location. How do we do? What is memory? No. BC? No. What is a variable? Correct. Correct. A variable is a named storage location. A file? No. And double no because it's got to be in the form of a question, right? As Alex would do. He'd be like, no, you're wrong. Answer must be in the name. All right, variable. That would be, by the way, I'd still give you the points on the real one for that. But you got to say what is a variable in Jeopardy format. The first programmable device. A little bit of history. First programmable device. Jeopardy style. From the book, from the video that you watched on a snowy day, first programmable device. 5, 4, 3, 2, 1, 0. Stop. Who's got it? I won't count spelling. No. Nope. No. That punch card reader thingy from... I'd probably give you a make me chuckle extra credit point on that one. A computer, no. Mechanical calculator, no, no. ENIAC. By the way, the ENIAC is on display at the Air and Space Museum at the Smithsonian. Pretty cool to see, but no, that's not it. Oh, Jacquard's loom, yes! Except for it'd be a 0 in, on Jeopardy because it should be what is Jacquard's loom. But that's it. The auto loom, yeah. All right, so if you're like, what the heck is a loom? Look at your seat. Look at your chair, right? You see that pattern? See that pattern that is in that fabric? That comes off of a loom. Jacquard said, wouldn't it be cool is if instead we had to do that manually, we could program it to create a particular pattern, right? He did that without computers. It was all mechanical, programmable Pretty cool stuff. All right. We're almost done. Opposite of infinite. 20 seconds. Opposite of infinite. Don't forget, it's got to be in the form of a Jeopardy answer. Oh. 5, 4, 3, 2, 1. Stop. All right, let me see. Opposite of infinite. What is finite? Yep, finite is it. 0. No, just kidding. 0, 0, 100. Good job. All right, next. What are the steps to create a program with a class in Eclipse? I'll give you 1 minute. You've only done this a dozen or more times. You should have this memorized. Just how do we create a new program with a class? $30 seconds. $15 seconds. 5, 4, 3, 2, 1. Stop, please. Everybody, please stop. Okay, here we go. Let's see. File, new, Java project, right click, new class. Yep. File, new project, name it. File, new class. Yes. You might want to, and I wouldn't deduct for this, but don't forget that public static void main, right? Check on the public static void main, right? So that's it. File, new, program, file, new, class. You're good to go. All right? Next. Form of a Jeopardy answer. Best case, 1. Average case, n over 2. Worst case, n. 20 seconds. $10 seconds. 5, 4, 3, 2, 1, and stop, please. All right. What is a load? No. Sort, selection, sort. No. It's actually a sequential search. Efficiencies. Yeah, I would. By the way, I give you maybe a point here, a point there. You're pointing towards efficiency. Sequential search. It is. I'd probably give you a 5 for that. What is a linear growth rate? I'd give you a 5 for that. Yes, I give you 5 on both of those because that is a linear growth rate. How do we know? Right there on that worst case, right? Next. Following is an algorithm, true or false? 10 seconds. Go. Now I'll give you an extra 5 seconds. 5, 4, 3, 2, 1, and stop. If you're doing this on the exam, my recommendation is make sure that you draw out the boxes, right? So you say box X, put a 1 in it. While X is greater than 0, well, gee, X is already greater than 0. Repeat. Increment. It's still greater than. It's still greater than. It's forever greater than. Therefore, it is not an algorithm. It is false. Right? It is false. The first program member was a woman. 10 seconds. Five, 4, 3, 2, 1. Stop. You better bet you she was. Ada Lovelace. Ada Lovelace has a whole programming language named after her. We're going to skip that one. Don't worry about it. You still have doubts about this exam, true or false? Good. I got a lot of people that are confident. 40% of you are not. You got 48 hours. The best thing, the number one thing you can do to study for this exam on Tuesday night is to go to sleep at a good time. If you don't know it by that point in time, you're not going to know it. You're going to actually drop anywhere from 5 to 10 percentage points more because of sleep deprivation. All right? If you have any other questions, I'll be up here. Otherwise, I'll see you. Well, I won't see you. I'll have a proctor in here on Wednesday. All right?